Bismillahirrahmanirrahim. Dear student, today we will study that how to find out the oxidation number of an atom in a compounds. In the previous lecture, we have learned some rules that how to assign an oxidation number to an atom present in a compound or in a molecule. Today we will discuss that how can we find out the oxidation number of a compound with the help of some examples from your book. Now this is an example from your book. This is example number 7.3 of your book, which says a device called breath analyzer is used by police to test a person's breath for alcohol. It contains an acidic solution of potassium dichromate. It is a strong oxidizing agent. Determine oxidation state of chromium in it. Now this is an example in which potassium dichromate is given. You have to find out the oxidation number of chromium in it. As you can see in example, it is given that you have to find out the oxidation number of chromium that is present in potassium chromate K2Cr2O7. This is known as potassium dichromate. Now in its description, as you can see that this question is telling us about the uses of potassium dichromate, that it is used to test a person that either he has drunk or not by the policeman. Now you have to apply the various rules that we have discussed earlier in the previous lecture. So as you can see from the molecular formula of potassium chromate K2Cr2 and O7. Now what does this mean? It means we have 2 atoms of potassium, 2 atoms of chromium and 7 atoms of oxygen. So as you know that the oxidation number of potassium is +1. For potassium the oxidation number is +1 because it belongs to group 1A of the periodic table. Since there are 2 potassium atoms, therefore overall oxidation number will be 2 multiplied by +1. So this will give +2. So the oxidation state for one potassium atom is +1. Since we have 2 potassium atom, as you can see in the molecular formula, so we have to multiply 2 with +1, so it will give you +2. Now as you can see in the molecular formula, we have 7 oxygen atom. So in the previous lecture we have studied that whenever oxygen make compound other than peroxide or difluoride, then oxygen have -2 charge. Then oxygen have -2 oxidation state. As you can see that there are 7 oxygen atom and each oxygen atom have -2 charge, so we have to multiply 7 by -2, so it will give you -14. 7 multiplied by -2, it will give you -14. Now you have to find out the oxidation state for chromium, because in the given question it is saying that determine oxidation state for chromium. So for chromium you have to write, you have 2 chromium atom, so 2 chromium atom is equal to X. Because this is an unknown quantity, we have to find out the oxidation state for chromium. So now we have to make an equation, and that can be made like this. You have to write 2 multiplied by potassium plus 2 multiplied by chromium because we have 2 atoms of chromium plus 7 atom of oxygen, so we have to multiply 7 with oxygen. And since, as you can see, that potassium dichromate is neutral, so the overall charge will be equal to 0. As we have studied that potassium belongs to group 1A, so the oxidation state for potassium will be +1. So in case of potassium, you can write +1, and for chromium you have to write X, because you have to find out the oxidation number for chromium. So you have to write 2X and then plus, and then you have 7 atom of oxygen. As you can see that each oxygen atom have -2 charge. Each oxygen atom have -2 charge. So you have to write 7 into -2, and that would be equal to 0. So 2 multiplied by +1, as you can see, it would give you +2, and then you have 2x. This is just like a simple mathematics. And then +7 multiplied by -2, it will give you -14, and that is equal to 0. Then you have to solve this equation. So you can write 2x is equal to, now here in this side we have +2. Once it will move toward the other side of the equation, it will give you -2, and here you have -14, and once it will move toward the other side of equation, it will give you +14. So 2x is equal to -14 plus -2 plus 14, it will give you +12. Now as you know that this 2 is in the form of multiplication, so once it will move to the other side, it would be divided by 12. So x is equal to, it will be like this, 12 divided by 2, so it will give you +6. It will give you +6. Now what does this mean? This means that this +6 is the charge on chromium atom. This +6 is the charge on chromium atom. Now if you want to check that either you have done it correctly or not, so you can write it like this. You have K2 Cr2 and then O7. As you know that the charge on potassium is +1, so it will be +1. For oxygen the charge is -2, so once you multiply 7 by -2, it will give you -14, and once you multiply 2 by +1, it will give you +2. And for chromium, from this we have got +6, so we can write +6 over here. We can write +6 over here. So 2 multiplied by +1 for potassium, you will get +2. 2 multiplied by +6, you will get what? 6 multiplied by 2, you will get 12. So +2 and +12, you will get +14. And similarly for oxygen you have -14. So +14 and -14, what you will get? You will get 0 answer. So if you remember, there was a rule for oxidation state which we have studied in the previous lecture, that the sum of the algebraic sum will always be equal to 0 for neutral compound or molecule. So as you can see that the algebraic sum is equal to 0. Now we have another example from your book, that is example number 7.4, which says that boric acid having formula H3BO3, H is hydrogen, B is boron, and O is oxygen, is used in eye wash. What is the oxidation state of boron in this acid? So now you have the molecular formula for boric acid, that is H3BO3. You have to find out the oxidation number for boron in this acid. So as you know that the molecular formula is given, and that is H3BO3, which means we have 3 hydrogen atom, 1 boron atom, and 3 oxygen atom. Since hydrogen belongs to group 1A of the periodic table and it is not making any type of metal hydride, so the oxidation state for hydrogen is +1. How many hydrogen atoms are there? We have 3 hydrogen atom, so we have to multiply 3 by +1. So 3 multiplied by +1, you will get +3. Oxygen, you have 3 oxygen atom, and oxygen is not making peroxides or difluorides, so it have -2 charge. It have -2 charge. So there are 3 oxygen atom. For one oxygen atom, the charge would be -2. Since there are 3 oxygen atom, so 3 multiplied by -2, what you will get? You will get +6. Now for boron, you have to find out the oxidation state. Now as you know the method that how can we find, we have 3 hydrogen atoms, so you will write 3 multiplied by hydrogen, then plus, for boron you can write X, because you are going to find out the oxidation number for boron, and you have 3 oxygen atoms, so you will write 3 multiplied by oxygen, and as a whole this equation would be equal to 0 because boric acid is neutral molecule. So as you know that for hydrogen the oxidation number is +1. For hydrogen the oxidation state is +1, so 3 multiplied by +1. Similarly X, we have to write X for boron, and where we have 3 oxygen atom, and each oxygen atom have -2 charge, so that would be equal to as a whole 0. Now solve this. This is quite simple. 3 multiplied by +1, so you will get +3, and for boron again you have to write X, and once you multiply 3 by -2, what you will get? You will get 3 multiplied by -2 -6, and that would be equal to 0. So +3, once you move, once it will go on the other side of the equation, it will be converted into -3. So you can write X is equal to -3. You have this -x, once it will move toward the other side of the equation, it will become +6. So solve this. -3 +6, what you will get? You will get +3. So this is the oxidation state for boron that is present in a boric acid. Now if you want to check that either we have done it correctly or not, so you can write it like this. We have H3BO3, this is the formula for boric acid. So in case of hydrogen the charge is +1. In case of boron we have find out that the charge is +3. So in case of boron we have to write +3, and in case of oxygen charge is -2. So now 3 multiplied by +1, it will give you +3, and for boron you have +3 charge, so you can write +3, and for oxygen 3 multiplied by -2, it will give you -6. So +3 and +3 you will get +6, and for oxygen you have -6. So +6 and -6, as you know, they would cancel out and you will get 0 as a result. What does this mean? It means that we have calculated the oxidation state for boron correctly, because the sum, algebraic sum, is equal to 0. Now this is self-assessment exercise 7.3 from your book, which says that one major problem of air pollution is the formation of acid rain. Air pollutants such as sulfur dioxide, nitrogen dioxide combine with oxygen and water vapor in the air to form sulfuric acid and nitric acid. These acids fall to the ground with the rain, making the rain acidic. Cloud can also absorb the acid and carry them hundreds of kilometers away from where the pollutants are released. Now determine the oxidation number of nitrogen in nitrogen dioxide and HNO3, which is nitric acid, and sulfur in sulfur dioxide and sulfuric acid. So in this question there are 4 parts. We have to find out the oxidation state for nitrogen in nitrogen dioxide and nitric acid, and sulfur in case of sulfur dioxide and sulfuric acid. So let's proceed with nitrogen dioxide. So now in this case you have to find out the oxidation state for nitrogen. So oxygen have charge -2, so for nitrogen you can write X. For oxygen you can write 2 multiplied by oxygen, and as a whole that is equal to 0. So for nitrogen X, for oxygen the charge is -2. For in case of oxygen, in place of oxygen you have to write -2, and that would be equal to 0. So X is +2 multiplied by -2. What you will get? You will get -4, and that will be equal to 0. So X is equal to +4. Now this is the oxidation state for nitrogen atom in nitrogen dioxide. Now if you want to check, so you can check it like this: NO2, nitrogen dioxide. As you know that the oxidation state for nitrogen is -2, so you have to write -2, and for nitrogen we have find out that the oxidation state is +4. So for nitrogen +4 and oxygen 2 multiplied by -2, you will get -4. So what you will get from +4 and -4? You will get 0. So if your answer is equal to 0, the algebraic sum is equal to 0, it means you have done this question correctly. Now you have to find the oxidation state for nitrogen in nitric acid, that is HNO3. So now for hydrogen the oxidation state is +1. So you can write it like this: hydrogen plus nitrogen plus 3 multiplied by oxygen, that would be equal to 0. So for hydrogen the oxidation state is +1. Nitrogen you have to find out, and for oxygen the oxidation state is equal to -2, and as a whole it is equal to 0. So solve this equation. You will get +1 plus x, 3 multiplied by -2, you will get -6, and as a whole it is equal to 0. Now this plus 1 and plus minus 6 once moved toward the other side of equation, plus 1 would be equal to minus 1 and minus 6 will become plus 6. So x is equal to minus 1 plus 6. What you will get? You will get plus 5. Now this plus 5 is the oxidation state for nitrogen that is present in a nitric acid. This is the oxidation state for nitrogen that is present in a nitric acid. Now if you want to check, you can check it like this. You have HNO3. For hydrogen, the oxidation state is plus 1. For nitrogen, as we have find it out, that is plus 5. So you can write it plus 5 in place of nitrogen, and for oxygen the oxidation state is minus 2. So plus 1 and plus 5, and once you multiply 3 with minus 2, you will get minus 6. So plus 1 plus 5, you will get plus 6, and on the other side for oxygen it is minus 6. So once you cancel them, the algebraic sum will be equal to 0. You will get 0. Now we have to find out the oxidation state of sulfur and sulfur dioxide. That is quite simple. You can write sulfur dioxide like this, that is SO2. Now for sulfur you can write X, and for oxygen the charge is minus 2. So 2 into oxygen as a whole, it is equal to 0. So X plus, for oxygen the charge is minus 2, and as a whole it is equal to 0. So X plus 2 minus 2, you will get minus 4, and that is equal to 0. You have to multiply 2 by minus 2. So once you multiply 2 by minus 2, you will get minus 4. So once this minus 4 will move toward the other side of equation, what you will get? You will get plus 4. Now what is this plus 4? This plus 4 is the oxidation state for sulfur atom in sulfur dioxide. Now if you want to check, so you can check it like this. You will write SO2. For oxygen the charge is minus 2, and for sulfur you have just find it out, that is plus 4. So plus 4, and once you multiply 2 by minus 2, you will get plus 4. That would be equal to minus 4. 2 multiplied by minus 2, that is minus 4. So once you cancel them, plus 4 and minus 4, you will get 0. Now the last part is, you have to find out the oxidation state for sulfur and sulfuric acid, H2SO4. That is quite simple. For hydrogen you have to write plus 1. For sulfur you have to write X, and for oxygen you have to write minus 2, and as a whole algebraic sum would be equal to 0. So 2 multiplied by plus 1, you will get plus 2, and then X plus 4 minus 2, once multiplied you will get minus 8, and that would be equal to 0. So X is equal to minus plus 2. Once it will move toward the other side of equation, it will become minus 2, and minus 8 will become plus 8. So minus 2 and minus plus 8, that would be equal to plus 6. Now this plus 6 is the oxidation state for sulfur in sulfuric acid. Now if you want to check it, you can check it like this, H2SO4. As you know that for oxygen the oxidation state is minus 2, for hydrogen that is plus 1, and for sulfur we have found it out that is the plus 6. So 2 multiplied by plus 1 you will get plus 2, for sulfur that is plus 6, and for oxygen 4 multiplied by minus 2 that is equal to minus 8. Plus 2 plus 6 that will give you plus 8 and minus 8. So plus 8 and minus 8, these both will be cancelled out. So the final result would be equal to 0. So this is how you can find out the oxidation state of any atom in a compound or in a molecule.